space investigation has played an urgent role in unraveling the mysteries of existence. Initially planned for only 4 years, the interstellar pioneers set out on a significant journey that extended far beyond its intended duration. Launched in 1977, the Voyager rockets turned out to be remarkably resilient pioneers, exceeding expectations and rewriting the textbooks of planetary science as they traveled through the depths of space. Voyager 1 and Voyager 2 provided humanity with unprecedented insights into the outer reaches of our solar system. These brave probes captured stunning close-up images of Jupiter's swirling storms, Saturn's grand rings, and the detailed landscapes of their diverse moons. From the icy waters of Enceladus to the volcanic eruptions on Io, each discovery revealed a dynamic and complex universe that challenged our understanding of planetary processes. Voyager 2, in particular, etched its name in the annals of space exploration by becoming the first spacecraft to approach Uranus in 1986. Its flyby revealed a mysterious ice giant surrounded by an atmosphere of hydrogen, helium, and methane. Only 3 years later, Voyager 2 made history again as it sailed past Neptune, providing humanity with its first-ever close-up look at the distant blue planet and its enigmatic moon, Triton. Perhaps the most remarkable aspect of Voyager's journey lies in its perseverance. Despite traveling over 14 billion miles from Earth, the spacecraft continues to communicate with scientists, sending back valuable data about the interstellar medium it now crosses. These groundbreaking space probes, comparable in size to a vintage Volkswagen Beetle, have surpassed all expectations and continue to push the boundaries of human understanding of the universe. The extraordinary journey of the Voyager probes began with a daring gravitational assist from Venus, a maneuver never before attempted by any spacecraft. This decision showcased the innovative spirit of the mission, setting the Voyagers apart as true pioneers in the realm of space exploration. Navigating through the vast expanse of space was no easy feat. The margin for error was incredibly slim, with deviations measured in mere minutes, highlighting the precision required for such interstellar travel. It took numerous careful efforts to ensure each part of the journey was meticulously planned and executed. As the probes embarked on their journey toward Jupiter, they ventured 10 times farther from Earth than the nearest planet, Mercury. Their path led them through the perilous asteroid belt, a region of space filled with countless celestial bodies, each posing a potential threat to the mission's success. This journey through the asteroid belt was a subject of intense debate and speculation among scientists and engineers in the 1970s, as the exact density and composition of the belt were not fully understood at the time. Despite these uncertainties, the earlier Pioneer 10 and 11 probes blazed a trail through the supposedly dense asteroid belt unharmed, proving that such a journey was indeed possible. This achievement not only demonstrated the resilience of the spacecraft but also paved the way for the revolutionary Voyager missions. However, the challenges for the Voyager probes were far from over. As they ventured deeper into the universe, they encountered various obstacles and mysteries, each presenting new opportunities for discovery and innovation. With a mere 69 kilobytes of memory, barely enough to store a small image file by today's standards, the Voyager spacecraft faced a monumental challenge as they embarked on their voyage. Their memory capacity was equivalent to only a fraction of what the average smartphone can hold, underscoring the incredible ingenuity of the engineers who designed them. These fearless explorers relied entirely on their onboard intelligence to navigate the vast expanse of space. To put it in perspective, imagine charting a course through an endless ocean with only a compass and your wits to guide you. That's the level of sophistication the spacecraft operated at, before the era of cloud computing and high-speed internet. The data collected by the instruments on board was stored on old 8-track recording devices, the same kind of tapes grandparents might have used to listen to music in their cars. It's awe-inspiring to think that such outdated technology was responsible for preserving the significant scientific discoveries made by the Voyager missions. Despite their limited resources, the Voyager spacecraft communicated with Earth using a transmitter that was about as powerful as a refrigerator light bulb. Yet, with the help of massive 12-foot wide dish antennas, they managed to send and receive signals across the vast reaches of space. Imagine being so far from home that it takes over 18 hours for a message to reach its destination. that's the reality of the signal sent by Voyager 2 as it ventured deeper into the universe. Every bit of data, every image, every whisper from these distant Voyagers had to cross unimaginable distances before reaching the eager ears of scientists back on Earth. As the Voyagers traveled farther from Earth, they had to contend with interference from all sorts of man-made devices, radios blasting music, TVs broadcasting shows, and the endless chatter of cell phones. Despite facing numerous obstacles, the Voyagers have defied the odds and continue to surprise astronomers with unexpected discoveries. Their journey through the interstellar void has not only rewritten our cosmic playbook but has also transformed our understanding of the unknown realms of space that extend far beyond our solar system. One such mysterious event is the enigmatic Oort cloud, a celestial gathering of comet-like objects held together by the gravitational pull of the Sun, stretching halfway toward the nearest star. It remains a distant and intriguing region, and the Voyagers are slowly but steadily making their way toward this fascinating goal, hoping to unlock its secrets and understand its role in shaping the architecture of our solar system. However, the journey through interstellar space, where the solar wind phenomena give way, offers a more accessible frontier for exploration. Here, the heliopause marks the boundary between our solar system and the vast expanse of interstellar space, signaling the beginning of unfamiliar territory. It's a region where the influence of our Sun wanes, and the immense power of the interstellar medium begins to assert itself. Estimates of the heliopause distance were conflicting, with some suggesting it to be around 5,050 astronomical units. This uncertainty sparked a surge in funding for the Voyager mission as scientists sought to shed light on this critical boundary. However, as the spacecraft departed from this milestone, scientists were astonished to find no expected signs of interstellar travel. This surprising revelation sparked intense debate and led experts to re-evaluate existing models of interstellar space travel and the dynamics of the heliosphere. Additionally, the Voyagers have also provided invaluable data on the composition of the interstellar medium, offering insights into the vast cosmic environment beyond our solar system. This data has revolutionized our understanding of the universe and opened up new avenues for exploration and discovery. Disclosure, as the explorers proceed on their venture into the obscure profundities of space, addresses mankind's voracious interest and steady quest for information, pushing the limits of what they imagined and uncovering the secrets of the universe one revelation at a time. One of the most profoundly anticipated science research missions was the confirmation of our journey into the uncharted region of interstellar space, marked by the abrupt flood of highly energetic particles known as cosmic rays. These particles, often originating from cosmic explosions and other cataclysmic events, travel at speeds approaching the speed of light. While these cosmic rays represent a critical danger to spacecraft and even human astronauts, the majority of lower-energy particles are effectively deflected by the massive magnetic shield created by our Sun's heliosphere. This shield serves as a protective barrier, safeguarding our inner solar system from most external cosmic threats. As the Explorer spacecraft continued its extraordinary journey into the interstellar medium, researchers were not only monitoring the increase in cosmic rays but also analyzing any adjustments in the prevailing magnetic field. This magnetic field is influenced by the ionized gases permeating interstellar space and the nearby stars. The assumption was that this magnetic field direction would differ from the field within our heliosphere. However, despite these expectations, the Explorer probes reported no noticeable changes in the magnetic field as they ventured further into interstellar space. This surprising observation baffled analysts and added to the mystery surrounding the exploration beyond the boundaries of our solar system. The absence of anticipated changes raised intriguing questions about the nature of the interstellar medium and the interactions of significant events within it. This revelation underscored the complexity of space exploration and highlighted the need for continued investigation and observation to unravel the mysteries of the universe. On August 25, 2012, Voyager 1 achieved a notable milestone by penetrating through the heliopause, the outer limit of the heliosphere, the vast bubble of charged particles and magnetic fields created by the Sun. This event marked the first time a human-made object ventured into interstellar space beyond our solar system. Voyager 1's journey to the heliopause spanned an astonishing distance of over 14 billion miles from Earth, showcasing human ingenuity and the remarkable capabilities of space exploration technology. As it traveled into this strange domain, Voyager 1 continued to send valuable data back to Earth, providing insights into the conditions at the outer reaches of our cosmic neighborhood. Scientists eagerly awaited Voyager 1's transmissions, hoping to gain new information about the characteristics of interstellar space. They anticipated observing an expected increase in plasma density, a measure of the concentration of charged particles, as Voyager 1 moved past the heliopause. However, what puzzled them was the absence of any significant change in the direction of the surrounding magnetic fields, which had been expected to alter as the spacecraft transitioned from the influence of the Sun's magnetic field to that of the broader interstellar medium. Fast forward to November 2018, and Voyager 2, the twin spacecraft to Voyager 1, embarked on its journey to the heliopause. Like its predecessor, Voyager 2 traversed immense distances and communicated crucial information back to Earth, enhancing our understanding of the outer limits of the solar system. Despite the excitement surrounding Voyager 2's arrival at the heliopause, researchers were again perplexed by the data it transmitted. Similar to Voyager 1, Voyager 2 detected no significant changes in the direction of the magnetic fields, challenging existing theories and leaving scientists grappling with new questions about the dynamics of interstellar space. These remarkable missions by the Voyager spacecraft not only expanded our knowledge of the universe but also highlighted the limitless possibilities of human exploration beyond the confines of our home planet. As these courageous probes continue their journey into the vast expanse of interstellar space, they serve as beacons of human curiosity and perseverance, inspiring generations to come to explore the unknown realms of the universe. However, the current models couldn't adequately explain this captivating anomaly when Voyager 2 finally reached its destination. The solar wind, a continuous stream of charged particles emitted by the Sun, was found to be at its strongest. This surprising observation indicated that the boundary of the heliosphere, known as the heliopause, could extend much farther than previously estimated, perhaps beyond the 120 astronomical units initially expected. As the Voyager probes ventured deeper into the strange domain where the solar wind meets the interstellar medium, they uncovered a wealth of intriguing information. Among the revelations were subtle yet significant small-scale changes occurring near the heliopause. These variations appeared to be influenced by the complex interactions between the heliosphere and the surrounding interstellar environment, providing insight into the dynamic nature of this boundary region. Despite the intricate changes observed on a smaller scale, the Voyager probes recorded surprisingly little variation in the magnetic field at vast distances. This revelation puzzled scientists and raised questions about the spacecraft's eventual escape from the heliosphere. Would they eventually break free from the Sun's influence and encounter the true magnetic field of interstellar space? Debate among experts intensified as some speculated that the probes might encounter a radically different magnetic environment beyond the heliopause. Explorer tests could, in any case, be inside the heliosphere, while others highlighted undeniable proof suggesting their venture into interstellar space. This proof included a notable increase in the detection of cosmic rays and plasma density, indicating a transition into a new cosmic domain beyond the influence of the Sun. Tackling this mysterious puzzle surrounding the heliosphere is like interpreting the complex dynamics of a goldfish bowl from the perspective of the fish inside. To gain a comprehensive understanding, scientists recognize the need for sending an interstellar probe capable of providing a valuable outside perspective on this fascinating boundary region. Amidst the rapid growth of technology, the explorers stand as striking relics of space exploration history. Created with creativity and foresight, these interstellar trailblazers are powered by a unique blend of vintage engineering and timeless innovation, venturing into the universe with equipment dating back to the 1970s. The explorers have a particular charm that captivates the imagination. Their sturdy frames house instruments made with precision, each component carefully designed to endure the hardships of space travel for decades. Despite the passage of time, these instruments continue to operate with impressive efficiency. The power source of the explorers is equally intriguing, utilizing the heat generated from the radioactive decay of plutonium, these spacecraft convert thermal energy into electrical power, a feat of engineering that has sustained their missions for over 50 years. This unconventional power supply has enabled the explorers to travel far beyond the reaches of our solar system, transmitting valuable data back to Earth with relentless determination. NASA's meticulous approach to managing the explorers' diminishing power supply highlights the agency's commitment to maximizing the scientific potential of these aging spacecraft. Every decision made by mission engineers is a delicate balance between preserving critical instruments and extending the explorer's operational lifespan. Despite facing challenges such as decreasing power output and extreme temperatures, the explorers continue to defy expectations. The magnetometer and plasma science tools are expected to be the last instruments to stop working, as they are nestled inside the spacecraft's main body, kept warm by the computer's heat. Other instruments are attached to a 43-foot-long fiberglass arm. If all goes well, scientists could stretch the missions of the explorers until 2030. However, the real game-changer is power. Regardless of challenges, the explorers will keep pushing forward. It's an incredibly long journey, spanning 16,700 years. Voyager 1 will swing past Proxima Centauri, our closest star neighbor, while Voyager 2 will do the same 3,600 years later. Then, they'll continue to orbit the Milky Way for eons, long after our Sun disappears and its protective bubble, the heliosphere, vanishes. These resilient spacecraft will still be there, mostly intact, unlike our small blue planet. Perhaps they may even send a final message during their endless journey. But if they do, it won't be through radio, and there won't be any humans to receive it. The Voyager adventure is a tribute to human exploration and scientific curiosity, pushing the boundaries of time and space.